So this is the car I'm going to hack. This is a Spider-Man remote control car that I got from Kmart, and it's I'm just going to turn it into a sweeping the floor robot. So what we can do is we can take this off and have a look at the electronics underneath, and this is fairly easy to take off with a pair of tweezers or pliers. So just has these little things that come out there. And now if we lift this up, we can have a look at the electronics underneath. So underneath is the motor electronics, and we have here a number of things. This is everything's quite labeled. So that says, you can see USB plus and USB minus, and this is the charging cable. And if you look at that, that's got a little B there. I don't think you can see it, and that's a little F there. So that's the back and that's the front. So a positive charge on this will be the front, and a positive charge on that will be the back. And then this one, see there's a little L there, so that's for left, and a little R there, so that's for right. And then we have the LiPo, I think it's a 7.4 volt LiPo battery, which connects in here and to here. So what I'm going to do, I'm going to cut all these along here, and then I'm going to attach the wires to my electronics. And then I've still got the battery charger, so I'm still going to leave this so I can plug it in here. And I've still got the radio control signals from here, which will come in here, which will come in at all these 4 points. So I'm going to try and use those, hopefully. So I'm going to connect to like an Arduino or something like and then I've got, this is a TB6612 MOSFET motor controller, and that's going to be in there as well. And then I've got these sonars to attach, and hopefully that'll be everything I need to attach. If I need to attach another radio control, then I will, but hopefully I can run it off all the signals from this one that comes with the car. So I've got 4 signals, left, right, up and down, and I'd have to figure out some way to use all of those for everything I want to do. Basically, I want to be able to switch it from automatic navigation into manual navigation, as well as control it. So I think I can do all that, and we'll see how it goes. Okay, so I've done a little bit of work. I've cut these wires here, and then I've soldered in some DuPont cables to these wires, which are coming from the circuit board over here. And then these wires here, where I've cut them, these are going to the front motor, and I'm going to put those into my motor controller. So now I've cut these, I'm going to just do a little experiment. I've connected up the multimeter, and I'm going to see what kind of voltage I get for a left turn and what kind of voltage I get for a right turn. Now, I think the voltages is going to be a little bit high because it's connected straight to the battery. So that's 6.67 for a right turn, and minus 6.67 for a left turn. So I'm going to test the gyroscope next. So I'm just going to wire my electronics onto a little solderless breadboard, and I'm just going to stick it up the front here of the car. So that's a good way to arrange it. So what I've done is I've just ripped these side rails off this breadboard. They just come off quite easily. And then I'm going to position one over here, so I can just have all my voltage positive and negative there. And then I'm going to put the Arduino just mounted on the top like that, see? And then I've got the electronics on here, which will connect to most of these ports up here, and I've got also a number of ports down here for connecting the stuff that needs to go on top of the car. So what I'm going to do, I've just got this light here. I'm going to make this change color when it hits a wall or something, just to see if this is effective. So this won't be connected yet to the car. I'll just have this connected, running off its own battery supply for now, and then I'll try to sort it all out once I've worked out the gyro. So I'm just doing this like one bit at a time. So this is the car so far. So what I've done is I've connected in an IMU, inertial measurement unit, which is a BMI 160, and I've connected this to the Arduino Mega, and then I've connected these LEDs, and these two LEDs will go from green to blue, and then will flash red when there's a collision, which is going to be detected by this. And I've got this magnifying glass here, which makes it much easier to read the pins on the Arduino, and this is quite valuable. If you can find a magnifying glass, it's really going to help you out. Okay, so I'm just going to stick the Mega in here with a little bit of blue tack, and it's quite fiddly. There's a lot of wires, but it'll fit in quite nicely. Now let's drive it around a bit and see if it works. Let's tuck that into there like that. Okay, so the two front lights are going to be red when the car is stopped, and green and blue when the car is moving, and they'll go red when the car crashes. So that's how I programmed the IMU, and I'll share my code in the description. So if you look at this now, see it's going green and blue, and then crash, it goes red, and then green and blue, and then red, red again. Okay. Alright, that's pretty much it. So the interrupt lasts for 2 seconds. I'll probably have to decrease the time on that. So the next step is to connect this up to the Arduino to see if I can run the remote control through the Arduino. So these are the white one, and the yellow one is for the front motor, which does the turning, and this red and black one here, these are for the back motor, which goes forward and backwards. So I'm going to have to cut these two, and then when I send a signal from the remote for forward, this will be positive, and the signal from the remote backward, this will be positive. So I'm going to feed these into the Arduino to get the remote control signal, and then I'm going to connect the other half to the motor controller, which is going to be connected back to the Arduino. So yes, I'm going to have to cut these, and these are the battery wires, which I'm going to cut as well to power the Arduino. Okay, so I've wired this up so that the outputs from the remote are not going to the motor anymore, they're now going to the Arduino. And maybe you can see a bit better with that. Yeah, so the yellow one that starts off at 31, 33, 35, 37. So the red one, which is forward, goes to 31. Black one, which is backward, goes to 33. And then the white one, which is right, goes to 35. And the yellow one, which is left, goes to 37. And then I'm just going to run that and print it out on the serial monitor to see if it works. Okay. So I've got the remote control here, and I'm just going to push it forward, and it says going back. And when I press it back, it says going forward. And now when I'm pressing it left at the right, at the moment it says going right, and left it says going left. So pressing it right, it says going right, and pressing it left, it says going left. Okay, so left is left, right is right, and forward is back, and back is forward. So that's good to know. So the next thing I'm going to do, I'm going to test the H-bridge motor controller with the motors on the RC car and the Arduino. I'm just going to set up some test code, make the motors go forward, backward, left, right, and see if that works. Alright, here goes. So that's running now with the test code. And I've just got it, actually the PWM signal set at 100. That's breaking, but that's running at 100. See, and it's actually quite fast. I could probably, if you really wanted to speed this up, you could probably just use the PWM. But I want to make this a little bit slower. So I'm going to, I'm probably going to have to lower that eventually. All right, after I do some testing. So I've cut these wires here where the battery was, and I've put these little connectors here. So what I might do is, I think I might plug this into the 5-volt power supply from the Arduino, because it's really only supplying the radio control, and that way I can get rid of these resistors that I put in to divide the voltage signal, which was coming from the battery before, and that was 6.6 volts, and now we're only going to have 5-volt input, so that should be okay for the Arduino. So I'll just explain how I've got the wiring on this. So the battery, which I'll start with, the battery here, which is coming from the car, which is a 7.4 volt LiPo, is being used to power the Arduino Mega and also the motor controller. So it's a source for both of these, and then I've got the 5-volt regulator from the Arduino Mega being used to power all the other electronics. And the way I've done that is I've passed it through with some jumper cables through this rail, which I've just taken off from a solderless breadboard. And then I've got 5 volts on the bottom and earth at the top, and I've got this running to the gyroscope, and I've also got it running to the board that came with the RC car, which I'm just using for the remote control. So I'm just using that to accept signals from the remote control, and then I'm outputting the signals from here back to the Arduino Mega through, so I've got it wired up with some pull down resistors, and I didn't actually end up using the divider resistors because now I'm powering this with 5 volts. I'm getting a 5-volt logic signal, which is a bit better than the 7.7 volts or 7.4 volts I was getting before. And then I'm also going to use this to power any other electronics that go in the car, such as a sonar distance sensor or a servo or anything else. Okay, and the other thing that's being used to power are the LEDs, which at the moment they're flashing because the car's not moving. So we'll see how those go once we get the car moving. And then I've got the remote control hooked up through the Mega, so I can give you a demonstration of that as well. And we'll see how that goes. Oh, hey everyone. So I've done a couple of things here. I've put a servo on the front, which is attached to an ultrasonic sensor, and one on the back as well, which is also attached to an ultrasonic sensor. So the car's going to move backwards and forwards, and when it's stopped, it will change direction, which is why it keeps changing direction now, because it's stopped. So that goes off, then this goes off. And the other thing I've done is I've added an extra battery here to power the motor. So these electronics here, the the Arduino will be powered off the battery that comes with the car, and then the motor will be powered off these two 18650s. And the reason I had to do that is because the car battery wasn't powerful enough to power the electronics and the motor together, and this battery is a little bit more powerful, so it seems to be doing a bit better. Now the other thing is I have to turn the speed up of the car really high, and the reason that is because there's not enough torque to drive the car forward with the weight of all these electronics on low speed. And also these remote control cars are built for speed rather than torque. So I mean, when you buy them online, speed is actually one of the selling points for these. So yeah, so I had to ramp the speed up. So we'll see how this goes. Okay, so this is the testing environment I've set up for the car, and there's a box in the way, a couple of boxes, and then there's a couple of table legs. So it might or might not detect the table legs from the ultrasonic sensor. So here goes the test. I'll just switch the motor on. Okay, so it went around the box, and then it's going to the table leg, and it's going to try to reverse back now. So I'm just going to take you through a few things in the code I've written, and this code is available on GitHub, so you can have a look at it in your own time. I'm just going to go over some of the things that I think are important. So I've included all the helper functions in their own .h files, and this just makes it easier for me to organize the code, so I don't have to scroll through thousands of lines of code in the main file. And I've just organized it based on the peripheral electronics that I'm using. So the gyroscope, the pixels, the remote control, the motor drive, and the servo. And the next thing I want to go over is a few of the parameter settings, because I think that's quite important. So the min dist equals 50 centimeters is the distance that the car will react to an object. So if it's more than 50 centimeters away, the car will ignore it, and if it's less than 50 centimeters away, the car will react to it. And the car I've used doesn't have very good turning circles, so that's why I've set it to 50. If I was using a car with a sharper turning circle, I could make this a bit smaller. So these are all the timing parameters here, and the manual drive is 100 milliseconds, which is how often it checks the remote signal when I've got it under manual drive. The auto drive is 440 milliseconds, which is how often the code will check the surroundings of the robot. And the reason why I have it at 440 milliseconds is because I need to take 4 readings from the ultrasonic sensor between each check. So there's 1 on the left, 1 on the right, and 2 in the middle. And I need 2 in the middle because it passes through the middle from left to right. So it goes middle, left, middle, right. So I need to leave time for the servo to move as well as take the reading. And according to the documentation on the servo, it takes 100 milliseconds to move 60 degrees. So this is something I'm going to have to look at speeding up. I'll probably have to eliminate the servo in the next design. Okay, so the other thing I wanted to show you in here was the timing. So the head move period is 105 milliseconds, and the wait after head starts moving is 83 milliseconds, which means we've got 22 milliseconds to take the reading. And these readings usually take around 30 milliseconds, and the way I've reduced the time to take the reading is I've reduced the maximum distance on the sonar. So if we look at the sonar, I've reduced the maximum distance from 400 centimeters to 200 centimeters. So with 200 centimeters, the time is, according to the new ping library, is about 17.4 milliseconds between readings. And with 400, it would be about 30 milliseconds. So we can reduce this even further and speed this up. Now, I did think about a time of flight sensor, which is a laser distance sensor. And I thought that would be really fast because it uses a laser. But these, the time of flight sensors actually run at 50 hertz, which means it takes 20 milliseconds to get a reading. So the time's limited not by the laser, but by the supporting electronics. So I've defined this autonomous variable to be true, but if it's set to false, then the car will go into manual drive, which means it'll call this function here in the loop, the manual drive function. So let's just have a quick look at this. So basically it just reads the signals from the remote, and if it reads a signal for forward, say, which is signal I, signal 0, it'll then call the robot control function. Or if it reads the signal for backwards, which is I equals 1, it'll call robot control 1, and left robot control 2, and right robot control 3. So let's just have a quick look at this robot control function. I want to show you something about that. I want to point something out about that which I think is quite important. So that's in motor drive stuff. And say we're calling robot control with I equals 0. So I equals 0 is forward. And now what it does is it checks if it's already going forward. And if it's not already going forward, then it sets it to forward. And if it is already going forward, then it doesn't do anything because it's already going forward. So there's no need to set it to forward. And the reason why you can't keep setting it to forward is because every time you set it to forward, you're going to reset the PWM signal. So if you do this too many times, then the car is going to stall. So basically what it does in the loop, let's say we just want to make it go forward. It goes, if want to go forward and not already going forward, then go forward. All right. So basically, imagine if we had something that we always wanted to go forward, and we just, instead of having this one here, we just said go forward. And then every time it would just make it go forward, we'd think that was okay, but it's actually not, because every time it calls this go forward function, it resets the PWM line, which causes jitters which causes the robot to stall and jitter. So we want to make sure that we don't set it forward or back or right or left too often, especially forward and backwards, because they need the most torque, the most power. Okay, so now I'll just take you through the loop really quickly. So we basically got the setup, which just sets up the timers and then waits 3 seconds. I just put this delay in here, this 3-second delay before the robot starts moving, in case I need to get out of the way or position the camera or something like that, or there's a wire I've got to check or something. So now here's the loop. So if is shocked, which just basically I've got the gyro to interrupt when the robot's still. And the reason I have to do that is because I don't have a rotary encoder, and I want to check if it's bumped into a chair leg or a towel on the floor or something that it can't pick up with the ultrasonic sensor. So if it's still, then it's going to just change direction. And then I've got just to change the color of the light every second. And this puts it in, this calls manual drive if it's not in autonomous mode. If it's in autonomous mode and it's moving forward, then it moves the front servo and takes readings from the front sonar. And if it's moving backward, it moves the back servo and takes reading from the back servo. And these functions here all have their own timers on them, so we don't have to put the timer in the loop. Now this function here just calls the update robot position every every 440 milliseconds at the moment, which I found was a bit slow because I have to have the robot moving quite fast, because otherwise it just doesn't have enough power to move. Hi everyone. So we saw in the last video that the reaction time of the robot is a little bit slow. So it bumps into the wall before it actually reverses back. And we'd like it to get close to the wall but not touch it and then reverse back. And the reason it's doing this is because the time between checking the environment, the time it waits, the interval it has to wait to check the environment is relatively long, because it has to wait for the servo to turn and get a reading and then turn back and get more readings, and the servo takes 100 milliseconds to turn 60 degrees. So what I've done is I'm just going to keep the servo still, and I'm going to put 2 servos on each side of each of these servos, and the way I've done this is by attaching them to the chassis. So I've got 2 here at the back and this one, so that's 3, and then 2 here at the front, and that one, so that's 6. And then as well, I've placed the LEDs on the roof of the chassis. So the way I've done that is I've just drilled some 12 millimeter holes in the roof, and I've just put these through with a bit of hot glue. So I'm going to wire all that up, and hopefully we'll get this running in the next scene. Thank you. Okay, so I've adjusted a few of the parameters. So take 3, we'll see how this goes. Okay. There we go. All right. Okay. Didn't hit that wall. Alright, round that box, but it hit that wall, okay?
1, 2, 3. Hi everyone. So we see that the car's still crashing into the wall, even though I've improved the response speed, the response time. So I'm going to see if it's the brakes on the car that's causing it to crash, or it's actually that the distance sensor isn't working that well at high speeds. So the way I'm going to do that is I'm going to change the LED color to pink. So the LEDs on the top are going to go pink just before it breaks. So that way I'll see how long it takes between the time it breaks and the time it actually stops.
Okay, here goes.
Hello everyone. So we saw we had to run the car really fast to get it to move, and it didn't really have a lot of power, and we couldn't really slow it down. So we were using this one here, which is built more for speed than for power, which is one of the selling points on this one. And I really wanted to attach this, let's get it the right way around, this floor sweeper to the front of the car, but we didn't have enough power for it. So I'm going to have to use a more powerful car to do this. So for the next remote project, I'm going to use this rock crawler here, which has a motor at the front and a motor at the back as well. So this is like a four-wheel drive, and it is a lot more powerful. It does go up hills and stuff a little bit better. So we'll see how that goes. And I did want to say, if you're going to buy a rock crawler, just make sure you shop around, because I found these on eBay for $29.98 Australian dollars, and I saw the same thing on Amazon for $94.02 Australian. So Amazon selling the same thing for more than triple the price. So you should really shop around. And the other thing I want to do is I want to replace the steering with a servo, because we saw the steering wasn't very good on the RC car I was using. So I think with a servo I can get more reliable turns. And I hope you enjoyed watching this, and hopefully I'll see you on the next project. Bye.